वेलकम बैक माय डियर स्टूडेंट्स, वेलकम बैक। स्वागत है आप सभी का। यूर ऑल वेलकम। हाउ आर यू ऑल बेटा, कैसे हो आप सभी? आर यू एबल टू हियर मी, सी मी? वेरी हैप्पी गुड इवनिंग बेटा। आयुष, शिवा, तरुण, सुष्मित, नंदी, मेहना एंड ऑल। ऑडियो वीडियो कंफर्म में बेटा? इज इट क्रिस्टल क्लियर? वेरी हैप्पी गुड इवनिंग बेटा। क्या दास? ऑडियो वीडियो क्रिस्टल क्लियर टू ऑल ऑफ यू? Crystal clear, sir. Okay, fantastic. Mind blowing, super. So now we are in lecture number 20, and today's topic is kinetic search methods. The rate expression that you got. Now we are going to search that how we got that order. Like if second order reaction, first order reaction, or 1.5 order reaction. Okay. So once again, you're all welcome. As you already said, Gaurav Shrestha sir from Engineers Institute of India, India's best chemical engineering institute for GATE 2026 preparation. I had 14 plus years of teaching experience as GATE chemical engineering author, educator, multiple GATE top ranks, CIR 43, 2025. So first I want to ask you beta, you had completed this homework or not? Homework सबने complete किया या नहीं किया? Tell me everyone beta, please tell me. Homework completed or not? Homework completed or not completed? Tell me beta everyone. सभी बच्चा लोग ने homework कर लिया था? Done. Okay, so just now compare. Just compare beta. This should be K1CA. Here it's rate of appearance or formation you have to write. Okay, so it is formed by K1CA and also it is formed by K3CC and disappeared by K2CB. When you are going to write for this RC, so rate of formation C formed by 2 second path, that is K2CB, and plus C is also forming by this fifth path, so you can write K5CD. Then this C also formed by this G 11th path, so you can write plus K11CG, and disappeared by 3, 4 and 12, 3, 4, 12. So K 3, 4, 12 CC. Okay. Now next RD. So D formation plus RD, so rate of formation, net rate of formation. So D formed by fourth path and seventh path. So you can write K4 CC and plus K7 CE. Okay. And D disappeared by path number 6, path number 5. So 5 and 6. So you can write K56CD. Okay. Similarly, you can write for E. So E, net rate of formation of E found by sixth path and ninth path, 6 and 9. So K6 CD plus K9 CF and disappeared by eighth path and 7 and 8. So K7 8 CE. Similarly, you can write better for F. So F net formation. So it is formed by just one path, that is K8 CE, and its disappearance by two paths, one ninth path and 10th path. So you can write K9 10 CF. Same to same you can do for this G. So G just formed by 12th path. No, it's from 10th number path. So CK10CF and as well as from path 12. So you can write K12CC and disappeared only by path number 11. Okay, so is it same to same beta? Can we proceed? Confirm me. Same to same everyone, no doubts. Now you can write these expressions for any type of reaction network, and if they are asking to uh, make a relation between two different components, so you can also divide any rate expression with any rate expression. Okay. Yes sir. Okay. Before moving towards a search method beta, I want to discuss one more case. Suppose case is like a plus b and this time r plus s. They are asking numerical on this case. So are you able to solve this one, beta? Hmm? Tell me, beta. Second order case. Second order reversible reaction. Now, the good thing here is a plus b plus c forming r plus s plus t. These can't be asked in examination because the things that you are going to see, derivations etc., are very very complex, and also for few cases analytical solutions are not there. Like here, analytical solution is possible, easy solution possible, analytical only and only if the case is given along with this equation, that ca naught is equals to cb naught as well as cr naught is equals to cs naught, and you can write it becomes equal to 0. So in your examination, if they are going to ask, they will ask this case, because if ca naught is not equal to cb naught, it is not possible to solve just analytically and very very easily. It will be very very complex. Okay, so only one case that can be asked in your examination, the case written by me, ca naught is equal to cb naught. And it is also, if the question paper is very very difficult, then they are going to ask it, but no need to worry. In similar manner you can deal this case too, beta. इसको भी वैसे ही deal कर लोगे. Like see, I'm not going to do complete derivation here, but I want to show you how to solve this. So clearly, forward direction at constant, suppose I'm writing k1, backward k2, so I can write k1 ca cb minus k2 cr cs. Further moving, I can write this as ca naught dxa by dt, and that becomes equals to, here I can write k1 because ca naught is equal to cb naught. So every time clearly mentioned a plus b, so 1a reacted with 1b every time. So ca and cb ratio will remain same during entire time of reaction. So 1 is to 1 will be maintained every time, automatically maintained by the reaction. Okay, so I can write here ca square. Similarly, here if no r no s is present, and if present they must be same to same, but for simplicity in your examination they are going to give you 0. Okay, so if they are 0, so here you can write simply cr cs as cr square. First you can write cr square because they are same. Now further moving, ca naught dxa by dt, now you can write here k1 ca naught square 1 minus x a whole square, and here my dear students you can write k2. And if a consumed is ca naught xa, then definitely r will be formed there ca naught xa, as well as s will form same to same ca naught xa. So ca naught xa, ca naught xa, so here my dear students you can write ca naught square x a square. Okay, is it crystal clear to all of you? Tell me everyone, beta, क्या यहाँ तक कोई डाउट है किसी को? Any doubts till now or all clear? Any doubts? All clear? Okay, so nothing is special. Things are going in a similar manner. C not cancel this CA, this CA. Now, see what we can do max with this expression. Analytical solution, up to which step it is easier for us. Okay, so dxa by dt, and here you can write k1, then ca naught, and 1 minus xa whole square. 1 minus xa whole square, and minus k2 ca naught xa, k2 ca naught xa. Okay, no, xa square. Now clearly you can see the differential equation that you are going to make will be very very difficult to solve. It is not an easier equation. ये एक आसान equation नहीं होगा. Okay, but further moving, if you want to solve this, so you can write like k1 ca naught, and here 1 plus xa square minus 2xa, and minus k2 ca naught xa square. Further moving, just open this bracket, beta, k1 ca naught plus k1 ca naught xa square minus 2 k1 ca naught xa minus k2 ca naught xa square. Further moving, you can write K1 CA naught plus, clearly you can see, you can take common CA naught XA square, CA naught XA square, so you will get K1 minus K2, and further moving, minus 2 K1 and 2 CA naught into XA. Further moving, you can take CA naught common here, so after taking it common, you can write K1 plus XA square, K1 minus K2 and minus 2 K1 XA. Okay, so clearly you can see the equation is not a easier one to solve. So definitely in your examination, the mostly that they can ask you, they can ask this differential equation to solve. Okay, they can ask, but they will give you differential equation in different manner so that easily you can solve. Here just you need integration beta. Okay, so it is going to become a very complex expression. Like here again, if you want to write at equilibrium, suppose this is your equation number 1. Okay, so suppose I am going to write at equilibrium, in similar case at equilibrium. So at equilibrium, xa will be equals to xae and dxa by dt, then it become equal to 0. So what we can write our previous equation this time, 0 is equals to k1 plus xa square k1 minus k2, xa square k1 minus k2 minus 2k1 minus 2k1 xa, and that becomes equals to 0. So where is ca naught? Because it is here, it is 0, so ca naught can't be equal to 0, so this become equal to 0. I can write this become equal to 0. Okay, so this expression, and here you have to write xae and here you have to write xa. So again, maybe they can ask you one of the expression, which one of the following is correct, and you can see this as an expression there, this as an expression there, that is equation number 2. And now from here you can put the k1 value to this expression, and again you can take common, then again a square form will be there, a square b square, and any formula may be used in that intermediate step. So clearly it is very complex for you, so no need to kill time here. Okay, so max to max they can ask this expression. Okay, now you can solve in similar manner, but this is not your homework and no need to do this. Okay, now you can solve it in similar manner. Okay बेटा, is it crystal clear to all of you? क्या ये सभी को clear है? After this, extra max, what they can ask now. So for this case, clearly ca naught plus cb naught will be equals to every time ca plus cb plus cr plus cs. Okay, this is one material balance for this case. And you can also write ca naught plus cb naught is equals to cae plus cbe plus CRE plus CSE. But are you able to understand these material balances? क्या ये आपको समझ में आ रहा है ये material balance? Tell me beta everyone, are you able to understand? Confirm me everyone, please confirm me beta. Are you able to understand? Okay. So if they are going to ask like this, I hope that still you are able to give answer. Okay, so max to max, if they are going to ask, they will ask just like some balance type case. Okay, Okay, just wait. अनुष्का विश्वास किया था, सुष्मित दंडी, आयुष, शिवा तरुण एंड ऑल कर ले जाओगे ये? इफ दे आर आस्किंग एनीथिंग रिगार्डिंग दिस, everyone able to do this? Okay, so no need to remember. Whenever they are going to ask in examination, just do these things. Equation number 3, equation number 4. Okay. Suppose CAR naught and CS naught is not 0. Then here you have to write in left hand side CA naught plus CB naught plus CR naught plus CS naught also. Then CA naught plus CB naught will be replaced by CA naught plus CB naught plus CR naught plus CS naught. Okay, beta. So now I hope that in your examination, if they are going to ask any type of kinetic related question, then definitely you are able to do it regarding batch reactor. Okay, yes sir, good evening sir, welcome beta Shan Mukherjee, again 20 minutes late, huh? Okay, so now today's first topic I'm going to start, that is kinetic search methods. Kinetic search method. What is the meaning of kinetic search method, beta? We are going to do experiments clearly, my dear students. Whenever, as I told you earlier, here what we are going to do, we are going to do experiments. That means these all are experimental method: integral, differential, initial rate, half life, Ostwald isolation method. These all are experimental method. But don't worry, if they are going to make a question in examination, then that experimental data they will provide you. Okay, but if they are going to ask, anyone going to ask you that kinetic search methods, how to search kinetics, what is the meaning of kinetic search method, that means you are going to search rate expression. Like if a reaction is writing like A is forming product, A is forming product. Okay, so its rate expression is Ra is equals to K Ca raised to power n. So you are interested to found it. In order it, you are going to find it. You have to find the value of n. So find it. And this finding is known as kinetic search methods. How we are going to find? With the help of these kinetic search methods. So heading name is crystal clear to all of you, beta. What we are going to learn in this heading? Is it okay to all of you, beta? What we are going to learn in this topic, everyone crystal clear, beta? No doubts at all? Sabhi ko clear? Come on everyone, tell me, just enjoy CRE, beta. Okay, so 5 methods are here. One by one I am going to discuss each method. Integral method, differential method, initial rate method, half-life method, Ostwald's isolation method. These methods also asked in many interviews. Okay, so please, my dear students, make first heading integral method. Integral method. Integral method. Okay, so what is integral method? I am going to discuss this integral method step by step. Like in step 1, what we are going to do. After this step, in step 2, what we are going to do. Then in step 3, what we are going to do. In step 4, what we are going to do. So step wise. Okay. So whenever you are going to find a rate expression, or you can say kinetics of a chemical reaction, whenever you are going to find the kinetics, or you can say rate expression of a chemical reaction, so you have to assume a rate expression first. How to assume? Like minus R is equals to minus dc by dt is equals to K and function of concentration. This function of concentration you can assume like first order reaction. You can assume like second order reaction. You can assume like 1.5 order reaction. You can assume like half order reaction. Sir, how we can assume correct? I'm not telling beta that you are assuming correct. If you are correct, then in final step, the graph will follow your expression. If no, then no need to worry. Again, start from step number one with a new guess. And don't worry, these guesses are not you are going to do manually. Just after putting in the software, and for that software, what you are going to put, the knowledge required here. Okay, and in that software, just you have to put the experimental values. Now, software automatically will check for which n value the graph is consistent. For which n value, that is for which order value the graph is consistent. Okay, so every time new guess till correct order obtained, correct rate expression obtained. So orally, please tell me, are you able to understand what we are going to do in integral method? If yes, then write crystal clear. Then I will start step by step description. Okay, very good, fantastic. Before moving forward, beta, one more thing I want to discuss with you. Just wait. Okay, I will discuss at the end of lecture. Okay, I will discuss at the end of lecture. अब ये start हो गया तो पहले इसी को देख लेते हैं. So step number one. Step number one. As I told you, assume a rate expression. Assume a rate expression. Okay, like if reaction is forming product, just I'm giving an example. Maybe more than one reactants are there, but no need to worry. If more than one reactants, then other methods are there. Integral method is a sub part of that next method. Okay, so this time a single reactant will be there, like A is forming product. Now you have to assume a rate expression, like Ra is equals to minus 1 by V dna by dt, and that is written as K function of concentration. Okay, K function of concentration. Or further moving forward, if here the moles are not increasing, so you can also write like dca by dt. If increasing, no need to worry, still the steps are remaining same, just differential equation or integral equation that you are going to form, the solution will be different. Okay, so this time you are assuming like K into function of concentration. So you have to assume this fc beta. You have to assume this fc, like one example I am giving you. Okay, assume like EFC is CA. Suppose I'm assuming CA. That is means I am assuming first order reaction. I am assuming first order reaction. Sir, is it first order? No, no, no. I don't know. I don't know, beta. It is first order or not. I don't know. Okay. If my guess will become will okay correct, then no need to worry. If not correct, again I will start from step number one with a new guess, like 1.5 order, like half order, or any order, any order. Okay. So step number one, you have to assume a rate expression. Now rearrange and integrate within limit. Step number two, rearrange and integrate within limit. So write step number two. So in this second step, what you are going to do? Rearrange and integrate within limit. Within limit. What should be limit, beta? When time t is 0, concentration of A is Ca naught. At any time T, the concentration is Ca. Okay. So now see here, dCA by dt is equals to, suppose you assumed Ca. Okay, like you assumed first order. If your assumption was second order, so you have to write here kCa square. If half order, then you have to write kCa raised to power half. Okay, and further moving, dCa by Ca, and that equals to k dt integrated 0 Ca naught T Ca. After integration, you will get minus ln of Ca by Ca naught, and that equals to Kt. And separate, every time you will get separate expression with respect to order. Like if a universal equation you want to make here, then you can make like this, minus Tca by function of concentration, that equals to K T Ca naught to Ca. Okay, and for this given case, this equation can be written as this equation. So please tell me what are step number 1, step number 2. Is it crystal clear? Can we proceed, my dear students? Can we proceed? Done? Okay, very good, fantastic, mind blowing, super. So now, my dear students, clearly you can see here, beta, that this is y and this is yum, this is x. Like a first order, then this is y, this is yum, this is x. Y is equals to mx. So now you have to plot a graph. So how you are going to plot a graph? Definitely you need the values of concentration with respect to time. So now the time comes for experiment. In step number 3, now you are going to do experiment. Okay, you are going to do experiment. In step number 3, you are going to do experiment. Okay. So write down step number 3. Now do experiment and obtain T versus Ca data. Do experiment in a batch reactor and obtain T versus Ca data. You can use some composition analyzer in your reactor. That composition analyzer will tell you time to time what is the value of concentration with respect to time. So see, so T versus Ca data. Okay, more data will provide you accurate value of order. Okay, so any number of datas, just obtain with the help of experiment this T versus Ca data. Once you got this T versus Ca data, then you have to obtain this minus integration Ca naught to Ca dCa by Ca value. dCa by Ca value. Like here for our gas, this can be written as minus ln of Ca by Ca naught. So see, you know Ca value, you know Ca naught. Ca naught was initial concentration. So you have to put different Ca. So it will give you different minus ln of Ca by Ca naught value. Okay, so you will get this all. If different order, then here instead of this minus ln of Ca by Ca naught, something different will be present. In right hand side only Kt will be there. After Kt, everything will be in left hand side here in this example. Okay. Once you got this beta, now you have to plot a beautiful graph. So step number 2, step number 4. Step number 4, plot a graph. Now plot graph, plot graph between. Clearly you can see y, this whole is y, or you can say this whole is y and this is x. On x-axis you have to take time t. So you can write plot graph between minus ln of ca, or you can write minus ca naught ca dca by dt, sorry, by ca versus time. Here, for our guess, if guess was first order, then here you can write minus ln of ca versus ca naught versus time t. This graph you are going to plot here. Okay, this graph you are going to plot here. Okay. Now plot a graph. Be careful what I am going to ask. Okay, with words. Tell me better. The graph must be a straight line. Here the graph that we are obtaining must be a straight line. The statement is correct or not correct? Tell me. Correct. Shivatarun. Shivatarun. Not correct, sir. Absolutely correct, beta. It can be correct, it can be not be correct. Means you are absolutely correct. Okay, so it is not, and we can't use must. It may be or it may not be. Suppose the graph that you are obtaining is like this. Okay, where this whole value for our guess we are writing here on y-axis ln of ca by ca naught. If we are getting like this, oh, we are very lucky that in just first guess our order is correct, and its slope will give you the value of k. So you can write here, if we got a straight line, if we got a straight line who follows expression, then our guess is correct. No need to do anything now. But if we got, or if the graph is not a straight line, not a straight line, then our guess is incorrect. Now guess a new rate expression and repeat all steps from step number 1 until until get a straight line, until get a straight line. Okay, so if you are getting graph, suppose between here ln of, or wait, suppose my dear students, the graph is coming like this. That means clearly our guess is not correct, and now we have to again guess a new rate expression, and now again you have to perform all steps, but no need to do experiment again. Okay, just you have to perform all steps. That means again you have to new guess, and now the this guess will give you new guess, will give you new expression, and you have to plot a new graph. That means just repetition of steps. Okay, is it crystal clear to all of you beta? Tell me, क्या आप सभी को क्लियर है ये? Is it crystal clear? Can we proceed? Very easy now. So now you can explain to anyone. Now you can explain this to anyone now. Very easy. Okay, yes sir. So now we can start second one. So please write down with a differential method. Second one is differential method. Okay, इसे उतार लो. Done. Chalo, very good. So now write down next one beta, differential method. Now what to do in differential method? Clearly in a previous method you had seen that some integration you used. You had used some integration. That's why it is known as integration method. Huh? Clear beta? Here, if this is differential method, that means something we are going to do, like some differentiation or some differential equation you are going to use. If someone asks you, then you can say yes, it is correct. Here differential, here we are going to deal in differential form, directly in differential form. How sir? See, step number one will remain same. Step one will remain same. Again you have to assume a rate expression. You have to assume a rate expression. Okay, like if a reaction is there, like A is forming product, so again you have to assume a rate expression like Ra is equals to minus 1 by V dNA by dt, or you can write if liquid phase reaction or gas phase reaction no moles are increasing or decreasing, then minus dC by dt is equals to K function of concentration, and you are here suppose again assume, suppose again you are assuming first order, again you are assuming first order. That means here you have to write Ca. Okay, so this is your step number one. Step number one is same to same as you had seen in a previous case, that was integral method. Now in second step, here the good thing that now directly you are going to perform experiment to obtain T versus CA data. So please write down the step number 2. Step number 2, perform experiment, do experiment, and obtain T versus, बात वही हुई, CA versus T data. Okay. Now, previously the data that you are going to write, maybe the interval you can use little bit large, but in case of differential method, the interval, time interval in which you are going to note the concentration value, this should be very very close one. And in actually in industries when you are going to perform this, no need to draw some table etc there. Automatically some composition analyzer is there in your reactor, and with the help of automatic devices it is going to draw a graph. Automatically it will draw a graph, beautiful graph for you. That means you will get the CA values for every time, like 1 second, like 1.0001 second, like 1.1 second, 1.2 second, 1.3 second, 1.4 second, 1.5 second, 1.6 second. For every value you have the value of CA, because the machine is there, and how the concentration going to change with respect to time, it is going to noted by the automatic device. बोलो समझ में आया? Are you able to get what just I told you? What happens in actually in industries here on theoretical way, we are seeing analytically, so we are telling that this and this should be, if you are going to make some numerical based upon this, then that interval should be closer one. Okay, so that the graph that you are going to get is a smooth graph. Okay, crystal clear beta? Can we proceed? One more time I want comment from your side. One more time I want comment from your side beta. Everyone please tell me. Okay, very good, very good, fantastic. Now plot CA versus T. Plot CA versus T. Oh, previously you had not plot CA versus T. This time in step number 3 you are going to plot CA versus T. So plot CA versus T. Step number 3. Step number 3. Plot CA versus T and obtain minus dCA by dt value for all CA. What I want to tell you beta? Now again just focus on this graph. So in this graph, this side concentration is available, this side time is available. Why sir? Because dy by dt you are getting, you want to obtain the value of dCA by dt. So dCA by dt, so CA should be on y-axis, dy by dx. Okay, so clearly the graph will start from concentration CA naught, initial concentration. The graph will start from CA naught. And now just I am drawing here a typical graph. Suppose the graph is like this. Okay, the graph that you are getting like this. So now this graph is suppose corresponding these points, this point, this point, this point, this point, this point. These are the points. Okay, these are the points that you used in order to draw this graph with the help of T versus CA data. Now, can you tell me how to get that dCA by dt with the help of this graph beta? कैसे निकलेगा? You have T, you have CA, but you want dCA by dt value. You want dCA by dt value corresponding to every time, or you can say corresponding to every concentration tangent at that point. Very good, beta Shivatrun. That means you are going to take slope at that point, or you can say you are going to draw tangent. Okay, so for every t you have CA. And now how to draw tangent? It's very easy. See, this is a tangent here. This will give you different value, this will give you different value, this will give you different value. So now in this manner you can say what is this? The slope of these lines will give you the value of dCA by dt. Okay, so clearly here if y minus sign is there, because clearly decreasing one. So suppose this is minus dCA by dt 1, and this is minus dCA by dt 2. So in this manner you can get different values of dCA by dt with respect to every given point. Okay बेटा बोलो सभी लोग, प्लीज टेल मी वन मोर टाइम. इज इट क्रिस्टल क्लियर? कैन वी प्रोसीड टुवर्ड्स नेक्स्ट स्टेप? आसान लग रहा है? आर यू फीलिंग easy? Very easy now. So clearly you can see every time the graph will not come like this beta, CA versus T. Okay, maybe negative order reaction. Okay, so negative first order, second order. Here the graph you writing like exponential one, but maybe something like different one. It will depend upon the order of the reaction. Here just I'm drawing a typical graph. For that graph you have to, with respect to average CA, you have to obtain the value of dCA by dt. Okay, now the question is why we are obtaining or interested in the value of dCA by dt? Because my dear students, this dCA by dt is nothing but RA, that is rate of reaction. So what should be our next step beta? Now you are going to plot RA versus FC. What I want to say you see, two things you can do, either RA versus FC, but RA versus FC if you are going to plot, it will be a little bit difficult for you. So what you have to do, see, this is step number 4. Step number 4. In few books, it is written that directly RA versus FC you can do, but more correct thing that you can do by using some logarithmic graphs. So what is step number 2? You know that RA and this RA is dCA by dt. And now my dear student, here you assume that K and CA raised to power, suppose nth order. You assumed suppose nth order. You assumed nth order. Suppose. So one thing is here that just draw a plot RA versus CA raised to power 1. It will be like this. And if it is not like this, if it is like this, that means the n value that you assumed is not correct. Okay, n value that you assumed is not correct. Okay, if 1 is correct, then it will come like this. If you assumed 1.5, then it will not like a straight line. Okay, so by using this, because any method is possible, because you have softwares, yeah, you have softwares. But analytically, if you want to see in on copy how to draw graph, so the easiest way to represent it, take logarithmic. So ln of RA, that can be written as ln of K CA raised to power n. Just use some mathematical basic mathematics, ln of RA, and that equals to ln of K plus ln of CA raised to power n. Okay. Further moving, you can write ln of minus RA, and it can be written as ln of K plus n ln of C. Now see this equation, beta. See this equation. How easy it is now. This is your Y, this is your M, X, this is your C. So this time you can plot a beautiful graph again. Again you can plot, and here no need to use any guesses. Automatically you will get the correct answer here. Like on y-axis you are taking what? Ln of minus RA. Okay, and here you are taking what? Sorry, it's ln of CA. You know the value of CA. With respect to that CA, you can obtain the value of ln of CA very easily. Now clearly this graph will be a straight line always. Here no need to worry. It will be always a straight line, and just a typical graph I am sharing here, because if negative order reaction, then it can go in downward direction. Okay, so if this is your graph, then clearly the intercept will give you ln of K, and by using ln of K you can write the K value. And now the slope, slope of this graph will give you the order of the reaction. Okay, so I hope everyone crystal clear beta. बोलो सभी को clear है? Is it crystal clear to all of you? Is it crystal clear, my dear students? Differential method is also crystal clear to all of you. Very easy ना? It's very easy. बोलो आसान लग रहा है कि नहीं? Just tell me, is it very easy? Very easy ना? Now in examination, what they can ask? They can ask you like statements in differential method of kinetic search. Minus RA versus FC graph plotted. This statement is correct or not correct? Yeah, statement is absolutely correct. Statement is absolutely correct. Okay. Or they can give graphs and they can ask to match the column. You can match it. Now first one is over, second one is over. Now third one is initial rate method followed by half-life method. So first I want to discuss half-life method. एक काम करो, wait. Wait. Just switching 3 to 4, 4 to 3. Nothing special. Wait beta. Okay. So write down beta. Third one, half-life method. First two completed. Now third one, please write half-life method. As the name suggests, half-life. That means here you are going to use half-life technique. Half-life technique. Now, how to use it? Again, it is very easy, just like first and second case. Here again you have to assume a rate expression. So step number one. Assume a rate expression. for the given reaction. Like Ra is equals to, if epsilon is equals to 0, so directly you can write dCA by dt. If not 0, what we can do, I will tell you just, I think in next lecture, or maybe one or two, after one or two lecture. So dCA by dt, and that becomes equals to k, and here you can assume like kCA raised to power n, and this can be like kCA, it can be kCA raised to power 0, it can be kCA raised to power 2, it can be kCA raised to power 1.5. Many infinite possibilities are there. Infinite possibilities are there. Okay, so just you are assuming something like kCA raised to power n. Suppose you assume nth order reaction. Now you have to find what is the value of this n. What is the value of this n? Now in step number 2, rearrange and integrate within limit. So step 2 is rearrange and integrate within limit. So here what should be our limit, my dear students? Again, time t is equals to 0. So Ca will be Ca naught, and when t becomes equals to t half, the concentration will be Ca naught by 2. Are you getting my words, beta? As the method is half-life method. So clearly now we are going to introduce that half-life here. What is T half? T half is half-life. T half is half-life. So what you will get? Minus dCA upon Ca raised to power n, and that becomes equals to k dt, and just integrate it. When time is 0, concentration is Ca naught. When time is t half, concentration is Ca naught by 2. Okay, so now just integrate it, beta. So further moving, you can write minus integration Ca naught to Ca naught by 2 and Ca raised to power minus n dCA, and right hand side is very easy to integrate, so I'm writing t half minus 1, that means t kt half. Okay, now integrate it, already integrated by you, so Ca raised to power minus n plus 1 upon minus n plus 1, and here the limit is Ca naught to Ca naught by 2, and here one negative sign is also present, and that becomes equals to k t half. Okay, so I hope that till now no doubts. Now just you have to rearrange it. First integrate it. Now put limit first. So it can be written as no 1 minus n. So minus will give n minus 1. You can write it like n minus 1. So k n minus 1 t half, and 1 upon Ca raised to power 1 minus n, 1 upon Ca raised to power 1 minus n. Here you can write Ca raised to power 1 minus n. So upper limit you can put here, and if you don't want to use that negative sign, no need to worry. If used, still no need to worry. Just put it, so it can be written as Ca naught by 2 raised to power 1 minus n, and minus Ca naught to power 1 minus n. Okay, now you have to take something common here, like you can take common Ca naught raised to power 1 minus n here. Ca naught raised to power 1 minus n, if you are taking it common. What left here? 2 raised to power 1 by 2 raised to power 1 minus n, or you can write 2 raised to power n minus 1 and minus 1 equals to k n minus 1 t raised to power 1 by 2. Okay. Further moving, you can write Ca naught raised to power 1 minus n, 2 raised to power n minus 1 minus 1 and whole upon k n minus 1, and that equals to t half. Take logarithmic both sides. So you can write ln of C naught raised to power 1 minus n into 2 raised to power n minus 1 and whole upon k n minus 1 equals to ln of t half. Log a, log b, log ab can be written log a plus log b. So again you can write ln of C naught raised to power 1 minus n plus ln of 2 raised to power n minus 1 upon k n minus 1 equals to ln of t 1 by 2. Now again log a raised to power b. Log a raised to power b can be written as b log a. So this can be written as 1 minus n ln of Ca naught plus ln of 2 raised to power n minus 1 upon k n minus 1 equals to ln of t raised to power, or you can say t half. Okay, it's very easy now. Now what to do? This is your final expression. Now you are going to perform an experiment and plot a graph, and the graph will be between, this whole will be your y, this whole will be ln of Ca will be x, this whole will be m, and this whole will be your c. So clearly you can see it is y is equals to mx plus c. So with respect to different initial this is not ln Ca. Please be careful. This is not ln of Ca. This is ln of Ca naught. This is ln of Ca naught. So again you have to take different initial concentration and you have to perform many experiment. Are you able to understand that for this case you need more than one experiment? In previous cases just you need one experiment, but here you need more than one experiment, na beta? Tell me everyone. Tell me everyone. Are you able to understand? Are you able to understand? Hmm? Yes sir. Yes sir. सब बोल दिया है sir. ए बेटा. How? Why you need more than one experiment? I can do again in just one experiment, यार. फंस गए again. Hmm? See, step number 3. Uh, step number 3. Perform experiment. Perform experiment and obtain Ca naught versus T half data. See my magic. So this is your Ca naught, corresponding to this Ca naught, this is your T half value. Okay. Many experiments you can perform, so on. Now Suppose I am taking CA naught as 200. It is going to give us something like half-life period as T1. That means when you are getting half-life period, but at that time the concentration is 100. So again, from 100 to 50, how much time required? Then initial you can take 50. So 50 to 25, how much time required? Again 25. So 25 to 12.5, how much time required? So in this manner, better just with the help of one experiment, you can write it like first experiment over, after over that, take that time, that that again just like initial concentration, एक बार फिर से उसको initial concentration के रूप में आप ले लो. समझ पा रहे हो? Are you able to understand? Like first half life, second half life, third half life, fourth half life, fifth half life, sixth half life, like this. If all half lives are same, automatically you can write the order is first order reaction. That means it is a first order reaction. Yes sir, understood. Fantastic, mind blowing, super. So here again not more than one experiment required. अभी भी आपको experiment कितना जरूरी है बेटा? Only you can perform with the help of one experiment. आप केवल एक experiment की मदद से कर सकते हो. And for more accuracy, you can repeat experiments. You can repeat experiments one more time with different initial concentration, with different datas. Okay. So यहाँ देख लिया graph. Now after this, obtain this data and you can write in the same step and plot ln of CA naught versus ln of T half graph. How sir? With respect to every CA naught you can got the value of ln of CA naught. With respect to every T half you can obtain the value of ln of T half. Okay, just obtain this one and now plot graph. Now plot graph. Okay, and this time the graph will be between ln of T half versus ln of CA naught. So ln of T half was on y-axis na, yeah, y-axis, ln of T half, and here you have to take ln of CA naught. Now clearly this should be a straight line. This graph should be a straight line with some intercept value. So the graph can be like this, it can be like this, it can be like this. Okay, what does it mean here? Sir, why you are getting different graphs? Because it will strongly depend upon the slope, and slope strongly depends upon the order. So clearly you can see, if slope is the positive one, if slope is positive 1, that means the value of 1 minus n is something positive, some positive value. Like suppose it is 1. So 1 minus n equals to 1. See, 1 minus n equals to some positive value. Say like 1. So 1 minus 1 is equals to n. So this is 0 order. Oh my god. If you can say here it is 0 order. Suppose it is that positive like 2. So 1 minus 2 is equals to n. Oh my god, this is less than 0. Suppose this positive is something like 0.1. So n 1 minus 0.1 will be n, and n is 0.9. अरे ये क्या हो रहा है रे भाई? Are you able to understand? Or some mistake? Tell me everyone beta. Yeah, very good. Because you are writing positive slope, so positive can be happen when n is -1, n is zero point 0.9, or n is 0. Okay, these all n you can see for positive slope, these all n's having value less than 1, every time less than 1. These all show you that n should be less than 1. Fantastic. It can be 0, it can be negative, it can be point, or it can be 0, it can be negative, or any positive value, but it must be less than 1. Similarly, my dear students, if you are dealing for n more than 1, if you are dealing for n more than 1, again similar thing here. 1 minus n, suppose the slope is -1, so like -1. So 1 plus 1 is equals to n. N is 2. N is 2. So clearly if n is more, example you can take like 1 minus n, suppose slope is -2. So 1 plus 2 is equals to n. See, n is 3. So clearly you can see beta, if this slope is -1, then n should be greater than 1. N will be greater than 1. Okay, and a straight line is possible when the slope is 0. When the slope is 0, that means it's for first order reaction. That means this is the slope. If straight line, clearly you can see half life is independent upon initial concentration, so it will be a just straight line horizontal to x-axis, parallel to x-axis. N is equals to 1. If positive slope means what? N is less than 1. N is less than 1, and if this comes, then that means n is greater than 1. And every time, what is the value of n, how you will get it? It's very easy, with the help of slope. With the help of slope. So in all these cases, the slope is 1 minus n. All these cases, the slope is 1 minus n. Okay beta, please tell me everyone, is it crystal clear? Is it crystal clear to all of you? And further moving here, see, the n increases in this direction, in this slope, from top to bottom. N increases. N increases. When order increases, the graph will shift in downward direction. With increase in order, the graph will shift in downward direction. So this can be also be asked in some theoretical way. So I hope each and every student is crystal clear that how to obtain n or rate expression or order of the reaction with the help of half-life method. बोलो बेटा, सभी को क्लियर है? Everyone crystal clear about this half-life method beta? Okay, so I'm giving you 1 minute break, just revision break, just revise it, and again then tell me all three methods are crystal clear, then I will move forward. Just revise 1, 2, 3. Method 1, method 2, method 3. Then I will proceed. Just write done in comment section. Just write done after revision, beta. In doubt, then ask me. Then, if no doubt, then I will proceed. Done. All clear. क्या बात, फैंटास्टिक, सुपर सुपर, बहुत अच्छे बेटा. So initial rate method. Now the beauty of this method is, in all previous method you had seen that mostly that method you are going to use individually if the reactant is a single reactant system, if single reactant system. But initial rate method can be used for single reactant system as well as if more than one reactant is available, still you can use this initial rate method. Okay, so suppose my dear students, two here, two A and B are available. Okay, so step one, again you have to write assume a rate expression. Okay, like suppose reaction is A plus B forming product. So assume a rate expression. Suppose the rate expression is like RA is equals to minus 1 by V dNA by dt. Suppose epsilon A is 0. So you can write like minus dCA by dt, and here it's K Ca raised to power alpha Cb raised to power beta. So now you have to find the value of alpha and beta. You have to find the values of alpha and beta. This is your beautiful equation number 1. Okay. Now, step number 2. Step 2 here is related with experiment. Okay. Now, what is experiment here, my dear students? First method was integral method. You had seen that in integral method some integration was used. That's why known as integral method. In second one, the tangent you used, differential form you used, so known as differential method. In third method, you had seen that the graph that you are using was between half-life. Again, experiment was there. That's why that method is known as half-life method. If here I am writing like initial rate method, what does it mean? That means here we have to check the initial rate. Initial rate means when t tends to 0, Ca is equals to Ca naught. The rate when Ca becomes equals to Ca naught. Okay. So in step number 2, do experiment and obtain RA values with different values of, or you can say different initial concentration, with different initial concentration. Okay, with different initial concentration. What does it mean? Again, you can use more than one experiment, or in the same experiment with different time, you can assume this is our initial rate. This is our initial rate with respect to that CA naught. Okay, so CA naught, CB naught, and corresponding to these, you are going to obtain the value of rate, and this is your initial rate. This is your initial rate. RA initial. RA initial means every time you are using initial rate with respect to that CA naught. Okay. So how much if you are using different mixtures, suppose at the same time? Why at the same time? Maybe, my dear students, the product is also going to affect the thermodynamics of the reaction. Maybe the product can also affect the thermodynamics of reaction. Then in that case, you need more than one experiment here. If that is a problem, that means every time just one experiment you can do and you can obtain the kinetics. It is not possible. Maybe you have to use more than one experiment. Suppose here the product is something product is going to change the things there in the reactor, like temperature or anything. Okay, or they are due to their intermolecular forces. Hmm? So suppose first time you are taking one experiment, you are doing one experiment, and you are taking initial consideration this as CA naught 1, and CB you are using CB naught 1, and initial rate you just note down, and suppose this is RA1. Now done. Use again separate reaction mixture if product affect. So CA naught 2 with respect to some CB naught 2, CA naught and CB naught is same to same, you have to take. No, it is not must. It's your choice. It's your choice. Okay, and here it will give you again initial rate like RA2. Again you have to use different concentration. Again you have to use different initial concentration of B, and suppose this time it is going to give you RA3. Now the question is how many such data required. In previous cases it was not fixed, but here how much data you need, it is fixed. Here how much data you need in order to get the uh, unknown order of the reaction, or in order to represent rate expression. Here the number of experiments are, how much you have to take is fixed. So how much experiment? It will depend upon number of unknowns of your reaction. Like, my dear students, can you tell me in this equation number 1 how much number of unknowns are there? Can you tell me equation number 1 how much unknowns are there that you need to search? कितने unknowns हैं बेटा आपके? Tell me everyone beta, how much unknowns are there? How much unknowns are there? 3. I use 3. Everyone, I want a comment from each and every student. Respond quickly. Shivatarun 4. Very good. 4. Kiada. Shushmandi 3. Tell me your unknowns. The unknowns that you are writing, please also mention with your comment. What is unknown there? क्या unknown है इसमें? According to 3 or 4, what 3 unknowns are according to you? What 4 unknowns according to you? अच्छा, आर ए की अल्फा बीटा की आर ए अल्फा बीटा beta Kia Dash and Siva Tarun. RA is not unknown to you. If RA is unknown, then CACB is also unknown to you. Clearly, you can see you with the help of experiment you got three datas. You got three datas. Okay, so clearly for this three unknowns are there. One is RA, one is this alpha, and one is this beta. So you need just three experiments. Why? So see step number three. Step number three. Make equations. That means here no graphs you are going to plot. So equations are minus RA1 is equals to K CA naught 1 raised to power alpha CB naught 1 raised to power beta. RA2 similarly my dear students for RA3. So RA2 you got when CA naught 2 used and when CB naught 2 used. Okay beta Shiva Tarun and Kiyadas, is it clear how three unknowns only? क्योंकि आप लोगों ने गलत आंसर दिया था, so please confirm me. Is it crystal clear now? Yes sir. Okay, very good beta. So clearly beta you can see here in this equation number 2, equation number 3, equation number 4. So clearly my dear students here you can see three unknowns, three unknowns, K, alpha, beta, three equations. So if number of unknowns equals to number of equations, then just solve it and get the values of solve it and get the values of K, alpha, beta. That's it. Done. So this initial method is also very easy. Tell me my dear students, sir, how do we measure it in experiment? But you are not going to measure it manually. Machines are there. They will give you values. They will give you values. Okay, that how much moles they will take very small differential time, and in that very small differential time how much moles are converted as per the volume available there. Okay, done. And you know beta the detailed balance that you had seen in yesterday's lecture, who had given, you know the name of Boltzmann? वो Boltzmann का theorem था, that one given by Boltzmann. Microscopic reversibility, that you had seen detailed balance principle. So if you want to mention there, then you can write Boltzmann. Ludwig Boltzmann, Ludwig Boltzmann. Okay. Name can be asked only in PSUs. Name can be asked only in PSUs. Okay, done. Can we proceed? Can we proceed towards next method? Ostwald isolation method, beta. Okay, very good. So you had seen first, second, and third, fourth method. You can use for single reactant, and the last initiate method you can also use for multiple reactant. But Ostwald's isolation method is used only and only if in your feed mixture more than one reactant are present. Okay, Ostwald isolation method is used only and only if more than one reactants are present. So you can write here used when feed contains more than one reactant. Okay, if more than one reactants are there in your feed. If single reactant is there, no need to see this Ostwald's isolation method. Okay, what is the meaning of isolation? Can you tell you? Suppose some one man is isolated by government. What does it mean? Isolated. That means now that man is not can affect our society. That man can't affect our society now. Are you getting this meaning? Yes. So the same thing here also we are going to do. Okay. That means if some reaction is there, suppose A plus B plus D forming product. Suppose a reaction is there, A plus B plus D, A plus B plus D forming product. Suppose this is a typical reaction. Any reaction can, maybe A plus B is only there. So just I am assuming one example here. I am assuming one example here like A plus B plus D forming product. Yeah, very good, Beta. And for this given reaction, suppose the rate expression that you are writing is Ra is equals to K Ca Cb Cd. Okay, and you have to check the values of this alpha, beta, gamma, as well as reaction rate constant K. It can be also written as minus dca by dt if moles are not changes or liquid phase reaction. Okay. Now this is your equation, and here now you want to calculate the values of alpha, beta and gamma. Now what to do? Suppose a chemical reaction is happened there. Suppose you take one general example. Okay, you are taking some food here. You are taking some food. Okay, this is, you are taking some food. Okay, and here on your, in your plate, on your plate, I am giving you too much portion of this vegetable, very huge amount of vegetable. I am giving you huge amount of vegetable. Okay, but I am giving you only two chapatis, or one chapatis I am giving you, then again after some time one more chapatis I am going to give you. Okay, in Hindi you can say roti, chapati. Okay, or you can say butter naan if more standard, lacha paratha. Now when you start taking your food, if I am going to increase some more vegetable here, it is going to affect your rate of taking this roti, or how you are going to take it is depend only upon this roti. Tell me everyone beta. That means this vegetable huge amount means it is in great excess than requirement. It is in great excess than requirement. So here clearly the amount of vegetable is not going to affect the rate of taking of that roti by you. The same thing is going to happen in the chemical reaction. If A and B and D are going to react with each other, if A, B and D are going to react with each other, so what you can do here, just like you had seen vegetable roti example, vege of what is this, vegetable roti example, vegetable chapati example. So same thing happen with your reaction similarly. How, sir? See, if A, B and D are going to react, A, B and D are going to react. Okay, and if B and D we are using in great excess, then the rate that you are checking there, the rate that is changes with respect to time, clearly it is going to depend upon the concentration of A only, na beta. Are you getting my words? Are you getting my words? Tell me everyone. Only it will affect RA? Only it will affect RA? Circle, can you explain one more time? Yes sir, okay, yes sir. But in your reaction mixture, suppose reaction is 111 is there, but you are using suppose 10 moles of this A, and you are using suppose like a 200 B and 200 D, then reaction can't be happen according to B now. If now after some time only 8 A is there, only 8 A is there, so reaction rate is decreases. Still if more than 100 B and D are there, so the thing that is going to affect is limiting reactant, and that is in limiting amount, and the other is in great excess, so that we are going to eliminate the effect on rate of reaction by B and D. Just like you can see, it is just like a constant there. It is just like a constant there. Every time the max amount that is required is present, but the A is not present there in that sufficient amount. So now with respect to time, it is going to affect your rate of reaction. Is it crystal clear to all of you, beta? Is it crystal clear? That means all molecules of A every time is totally surrounded by B and D. But all B and D are not totally surrounded by A. In Hindi, if you want to take feeling, if you want to feel it, so बेटा हर एक समय जो A का मॉलिक्यूल होगा वो B और D से घिरा होगा इंटरेक्शन करने के लिए, तुरंत B कहेगा मुझसे इंटरेक्शन कर लो, D कहेगा इंटरेक्शन कर लो। लेकिन जो बी और डी आपका हर जगह होगा वो हर समय हर जगह ए से घिरा नहीं होगा। सो बी और डी अगर थोड़ा बहुत घट भी गया तो स्टिल ए पूरी तरह से घिरा हुआ रहेगा, लेकिन अगर ए घटता जाएगा तो अब बी और डी और अपने आप को अकेला फील करता जाएगा। Okay, so the overall effect now, only thing that is going to affect here is the concentration of A, not B and D. Is it crystal clear to all of you, my dear students? Now tell me, is it crystal clear beta? Shushmit Nandi, very easy na, very easy. Okay, fantastic, mind-blowing, super. So what is our step number one here? What is our step number one if you want to write this like a step? So what is our step number one? You had taken B and D in great access. So now you have to take B and D in great access, then requirement. Take B and D in great access, then their theoretical requirement. Okay, you used above the theoretical requirement, so that you are isolating, see, isolation method. So you are going to isolate its effect on reaction rate. So and isolate its of its effect on reaction rate. बोलो बेटा, सभी को क्लियर है ना? डन? Very good. So now the rate expression can be written as minus RA is equals to K dash CA raised to power alpha, because that becomes constant. Just you had seen like catalyst in previous cases, pseudo reaction order cases, pseudo reaction cases, pseudo order cases, same thing here. Now K becomes K dash, in which CB and CD max concentration, according to max concentration values are there in that K dash. Okay, so this is your equation number 2. बोल बेटा, सभी को क्लियर? आराम से देख लो. आई एम गिविंग यू अगेन 30 सेकेंड. इफ एनी डाउट जस्ट फील फ्री टू आस्क मी. Can we proceed? What is the meaning of isolation? I hope everyone crystal clear. We are using a Schwartz isolation method this time again for determining reaction order. And you had seen this method is used when multiple reactants are involved. So here the idea is to isolate one reactant at a time by having the others in large excess so that their concentrations remain approximately constant. Okay. Here for a reaction like A plus B plus D forming product, you are going to conduct a set of experiments where all reactants except one, that is A, are in large excess. So clearly the reaction rate is now only and only depend upon the concentration of A. Okay. Now the question is how to get this alpha value. So now you can determine the order alpha with respect to A by any conventional method. That is differential method, integral method, initial rate method, or as well as you can say half life method. बोलो बेटा सभी को क्लियर हो गया ना? आसान है. इट्स अ वेरी वेरी इजी. So clearly it is pseudo. Its order is, can you tell me first, tell me its order. This time tell me order here. The order is. Can you tell me the order of reaction here? The order is, this reaction order is, previously order was alpha plus beta plus gamma. But this time the order is alpha, alpha. Everyone please give me, everyone. Order is, it's not alpha beta. This time order is pseudo alpha. If someone asks you, then please tell me it's pseudo alpha. Because the order is not alpha. But you are feeling like the order is alpha. Okay. So now step number 3. Now obtain alpha by any one of the conventional methods like integral method or differential method or half-life method or initial rate method. Very easy. Done. Now what to do in step number 4? What to do in step number 4? Now still your work is not completed, because just you got the value of alpha and you want the value of beta and gamma as well as, just like alpha. Okay. So now do same process to get the values of beta and gamma. Like my dear students, here you can write example for beta. For beta, A and D in great axis. A and D must be in great axis. And in next, when you are going to obtain gamma, that time A and B must be in great axis. This time they must be in great axis. Okay. So everyone crystal clear in this Ostwald's isolation method, beta? Very very easy. Very very easy. Similarly, you can obtain beta and gamma as you obtained alpha. आसान है. It's very very easy. But here, if someone asks you about limitations, then you can write limitation. No need to write every time everything every line here, because if from with every topic in every subject, uh, lots of common things are there. Like here, if someone asks you limitation, then you can say it requires large excess of reactants. So this is a limitation here. So clearly it is not practical, it is impractical for expensive reactants. If reactants are very very expensive one, then clearly you can't use this method. Okay, because in this manner this method is very very costly. Okay, and what is the advantage as well as initial rate method as well as this method? You are not going to solve, you are avoiding solving coupled differential equations. So this is a simple advantage you can say here. Similarly for all cases you can say what is advantage, what is disadvantage. Like wait, one more slide I'm making for you. Just copy paste of first slide, this one. So you had seen these five methods. See, wait, showing you. Okay, so if someone asks you simple limitations, advantages or disadvantages, sir, then don't worry. Like this method, the best thing here is it is easy one. It is easiest method. Okay, and differential, this is little bit complex one, because you have to take slopes, and clearly accuracy can be destroyed if you are not taken precautions, not noted accurately. In this method, less data required. Less data required. That means the data between T versus CA. But here, more data required. Here, more data required. Okay. Here, the problem you can say you have to do integration. Integration required. Integration required. If very very easy, then it is very very easy to perform. But if something like 1.73 and like this type of order or some complex reactions are there, then it can take time. Okay, and here what is the problem? Tangent required. Tangent required. And you know tangent, whenever you are going to calculate with the help of graph, like if this is graph, here someone can make tangent like this, someone can make tangent like this. So again you have to use precaution. Like in a half-life method, if you want to write something, then here more than one experiment required. Maybe you can write maybe, because maybe the product are going to affect the reaction kinetics. So in that case, maybe more than one experiment required. More than one experiment required. Okay, here again integration required. Integration required. And here also graph required. You have to plot graph. Graph required. Here also you can see limitations or difficulties. Graph required. Here also graph required. Okay, initial rate method, again more than one experiment required. But no integration or differentiation required. No integration or tangent required. This is good for here. It is good thing from here beta. But maybe complex equation solution required. This is limitation. And in initial rate, precaution or precision required, accuracy required while noting initial rate, because it is a initial, for what period you have to check it. So accuracy required while while noted initial rate. Okay. Similarly, for Ostwald isolation method, you can write the advantage that multiple reactant system you can modelize as single reactant system. So the good thing is here that multiple reactant system can be dealt as single reactant system, as single reactant system. So this is clearly its advantage. This is clearly its advantage. Okay. And further moving it, here also no need to solve differential equation, or differential equation is there, because you have to use again some above methods. So now it's a limitation you can write. What is the limitation? So you can't use if reactants are very expensive. अगर reactants आपका बहुत expensive है, like uranium etc., so you can't use this one beta if availability of that reactant is not enough in your country. Okay. And one more limitation similarly you can write: requires great excess of reactant, great excess of reactants. Okay. So I hope in this manner you can deal any topic beta. Okay. So tell me beta, these five methods are crystal clear to all of you? Any doubts, anyone, then you can ask me. Any doubt to anyone, then you can ask me beta. All things are crystal clear na? Asan hai, very very easy. Okay, fantastic. So for today, I think that's enough. Just one more time, I want to discuss these five methods in next 1 or 2 minutes only. Just a concise form. Please listen carefully. In integral method, guess after guess, take limit, integrate, and just put a graph, just like y is equals to mx. If graph is a straight line, your guess was correct. Otherwise, again take a new guess and repeat steps. In differential method, guess rate expression after guessing, done experiment with the help of experiment t versus ca data you obtained, and with that t versus ca data with respect to every ca, you have to obtain their minus dca by dt. After getting it, just plot a graph between ra versus ca raised to power n, or you can take logarithmic and you can plot between ln of minus ra versus ln of ca. And now the slope will give you the value of order. Yeah, that's a differential, and half life has advantage that it gives exact value of order. But everywhere you will get exact value beta, as well as integral too. Integral में भी मिल जाएगा. It depends upon you, and no need to worry. These things basically are done by softwares. But if you don't know these things, then how you are going to explain to that IT engineer that which software you need for this purpose? So that's why you are working here. Everything like IPC, when you are going to do modeling in industries, all modeling done by automatic softwares. Okay, but how you are going to tell IT engineers that which software, what software you want, what work you want from that software or from that app? Okay, that's why you need information, because you are chemical engineers there. So these things you have to explain them. That's why these things you are reading here. But the main thing that you are reading here, the first mission is for GATE examination or other PSU examination. So if they are asking in examination, mostly they will ask some theoretical way questions. Like in Osterwald isolation, they can ask you out of which one of the following kinetic search methods requires more than one experiment, and out of all one you will see Osterwald isolation method. So best take is Osterwald isolation method. Okay, if more than one, if MSQ is there and initial rate is also there, so take on initial rate as well as an Osterwald isolation method. Okay, but is it crystal clear to all of you? Half life, you used half life. Initial rate, used initial rate. That's why it is known as initial rate. Osterwald isolation, you had isolated the effect of other reactants at a time. Just you are taking one reactant. Okay. So tell me what everyone enjoyed today's lecture. मजा आया सभी को? All things crystal clear to all of you. कियादास बेटा tell me, clear हो गया ना कियादास? कियादास कर लोगी बेटा, समझ गई? Everyone please tell me, is it crystal clear? No doubts at all? So my dear students, at last the same thing I want to repeat, that a very good rank, the magic is revision. Okay, so I must do my revision daily, 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 I must do my revision daily. But don't forget these things. Definitely you will get rank 1, rank 100 or nearby any rank. Definitely is going to make a beautiful path for your dream job. Take care, all the best, love you all, a very very happy good night to all of you. Crystal clear sir, enjoyed sir. Me too enjoyed beta. All the best. You're all welcome beta, you're all welcome. Take care. You're all welcome beta. Ayush, Shivatarun, Shushmit Nandi, Kyadas. Okay, take care beta. Welcome beta. Shian Mukherjee, take care. Don't forget to revise.